bad.
It was
That was
amazing.
very bad.
All right, are you ready?
Always.
Okay, here we go.
I don't understand what it means by live love calculus.
Live.
Live. But thank you.
How am I supposed to know that?
He was joking.
I know.
Not this time. I didn't. It's like read and write.
X equals 0, x equals pi over 2, and cosine of x. Don't write it down. Let's just talk about it. From 0 to pi over 2, cosine looks like this, right? And then we keep going. And if I want to rotate this region about the y-axis, okay, well, our only option would be to do so with respect to x, right?
I think so.
All right. What method?
That's shell.
So 2 pi integral from 0 to pi over 2 of x times cosine of x dx. How do we integrate that?
With the calculator, math 9.
Without our calculator, math 9.
How does
the calculator do it?
Integration by parts.
Are we supposed to write this down? Not an image?
So you
Not
split
until
it
now.
up into the integral of x and cosine x.
Okay,
Let's cross that out.
so integration by parts is a way for us to integrate a product. Okay. I am going to go through how we get the integration by parts formula, if you will. I don't like calling it a formula. It's really more of a method, okay? But what is the why behind integration by parts? So, I have y equals u times v, where u and v are functions of x. Okay, well, how would we take the derivative? With respect to x, dy dx would be, we have to use the
Product.
okay, so the derivative of, I'm going to do it in kind of a strange order, but just trust the process, okay? So we have u times dv dx plus v times du dx.
Wait, do you want us writing down this proof?
She said yes.
Oh, we do. Oh, okay.
Why do they have to be like U's and V's?
Yeah, why is it gotta be a u and a b? That's like the same thing.
I get this
right?
complaint every year. I don't know.
I'm very bad at writing them differently. Make your V's pointy.
I don't understand how that's a problem. One has a tail, one doesn't. One's pointy, one's
Anybody
round.
else not right there?
I don't write it with
I
the
don't
tail.
write tail.
Who doesn't write their page? What's wrong with you people? Are you
You.
maniacs?
You.
You write you.
Okay.
You write you.
So let's write this in terms of the differentials.
Tails. No. That's how you write it. Otherwise, it's
No.
capital U.
It is a small capital.
Like this.
I see what you did there. Yeah. Don't question me.
Okay.
I actually see it too. That's weird.
Now, I want to integrate both sides.
Whoa.
E.
Oh.
Okay.
You're always with the other one.
Yes, this is true. What if I evaluate the integral dy? Then we get, okay. Yeah, technically, but yeah. I'm not going to write the plus c because we're still working with integrals that need to be evaluated, so we know the plus c will be coming with them also, okay?
Have you
All right.
always written your U's with the tail?
Always.
Or just like when you got them?
Nope, always. That's like how you learn it in school.
I don't think I've ever like that.
That's how-
Like my first grader comes home
Wait,
with.
so with the tail?
Oh yeah.
So your first grade.
I learned that in- I learned that in kindergarten.
That's not what I said.
It was
All right.
implied,
So now I am going to rearrange. I'm going to keep
No.
UDV, but then I'm going to subtract over the integral of V du. Are you okay with my math?
Oh god.
Just the rearranging of the equation,
I see.
You subtract.
okay? And we defined y to be u times v, right?
Yes. We did. We have no more y.
This, ladies and gentlemen, is integration by parts. The integral of u dv equals u times v minus the integral of v du.
But how do you evaluate like
Okay. How do you do that? So in our integral, we have to pick a u and a dv.
Mm-hmm.
With the u, we have to figure out what du would be. With the dv, we have to figure out what v is. So basically, we have to pick one part of our integral to integrate and one part of our integral to differentiate so we can throw it up there. Okay? So, let's go back to the integral we started with not knowing how to do. And let's just forget about the 0 to pi over 2, okay? Go ahead and write the integral of x cosine of x dx. For reference. Okay? So we have to pick two things out. We need to pick something to be dv and we need to pick something to be u. Now I'll tell you, whatever you pick for dv will be followed by the dx. I mean, that only makes sense, right?
I said we go with x.
Okay? My suggestion would be whatever you're going to differentiate, if there's a polynomial, okay? So since we have a polynomial piece, I would suggest using that as u because you're going to take the derivative of it, okay? And then cosine of x dx would be our dv, okay? Now, Richard, you probably get to the same place no matter what, but when you get,
This is what I meant.
that's what you meant?
Yeah.
Okay. Fair enough.
Wait.
Okay.
How do you know that cosine x is dv? Like, how do you? Because I know with like u and u, it's like the derivative that's dv.
Okay, so we have a product, right?
Yeah.
And our product is u dv. So I'm choosing a part of it, or part of our product to be u, and a part of our product to be dv.
So it's not the product isn't uv, it's u dv.
Yes,
Okay.
yes. So, what we're going to do, with u, we need to determine du.
Is it 1? Isn't that the
It is
derivative?
1
Well,
dx.
so is it just dx?
Yes,
Okay.
I'm making a point. Okay? To get v,
That's very loud. That's a sharp
it is. We would have to integrate, and what would v equal?
Science.
Don't worry about the plus c right now. Okay? So, u dv equals u times v minus the integral of v du. can we now do this integral?
Oh, yeah.
Wait, what?
So you. Okay, I got it. I'm there.
Anyone else agree? Yeah. So we have x sine of x minus the antiderivative of sine,
Negative cosine.
and then we'll put our plus c when we evaluate that v du integral.
Why would you ever need to know the area of cosine of x times x? If
For a
it's
math
that
test.
janky. Like that's just
Janky.
it's just nasty.
Well, if you're finding the volume of revolution
Uh,
around the y-axis of cosine of x from 0 to pi over 2, then you would need it, wouldn't you? Okay.
Wait, how would that work with this? Or are we gonna do that? I'll just go.
Wait, quick question.
Yes.
Shouldn't that be multiplied by 2 pi?
No, he doesn't know.
Well, it would if we were doing the area, but I just wanted to know how to evaluate the integral
Okay, I got confused.
aside from it.
I thought you
Yes.
said you were going back to that.
If we wanted to go back to it, we would need the 2 pi. Let's write this one down. Write it down. E to the x times x dx. Now, if this were e to the x squared, it would be a perfect candidate for u substitution.
Would.
E to the x squared.
I'd say that.
But it's too
Okay.
cool for that.
It is. It's e to the x times x. Okay? And this is something, when we're going through these strategies, before you look at integration by parts, you better see if you can do it by u substitution first. Okay? Because a problem that you can do u substitution with is not going to work out well for a integration by parts. They're separate entities. You can't do a problem both ways. It's one or the other. Okay? So make sure that u substitution isn't a candidate first before you try integration by parts. Okay? Okay. In this product that u substitution would not work out for, let's try integration by parts. So, like I said, I encourage you to use anything polynomial for your u. Do we have something polynomial? Okay. X is polynomial.
Sure is.
And then e to the x dx would be dv. So now everything that's in my integral is accounted for. Right? Okay. Which means du, once again, equals dx, because derivative of x is 1. And v, wait till I ask it, would be e to the x. Okay. So our integral is going to equal u times v minus the integral of v du. Doesn't this just all come together so nicely? I love it. I just love it.
That does work pretty well, I do gotta say.
It's great. Yeah, wait till,
Hard stuff.
how long do I have? 11:45, right?
I don't know.
Formulas.
I'll look it up.
We get up.
It's 11:45. So x, e to the x, minus e to the x plus c.
No.
You can, if you write this as e to the x times the quantity x minus 1 plus c, I have no problem, but it's not necessary. Okay? But it's fine to do it. I don't really care. Have we ever even talked about the integral of the natural log?
What time are you in today?
45.
Thank you.
No, we have not.
What?
We have not.
No, we haven't, because we can't do it without integration by parts. Now, if we don't know the integral of the natural log, should it be u or dv? Okay. So if u is the natural log of x, what's dv?
dx.
Okay. Well, this would make du 1 over x dx, and v would equal x.
Put it in. That's
Wait,
what
can we
chug,
go
as
over-
Mr. Gaffin says.
Can we go over why a natural log of x is x? I thought we wanted like a polynomial.
Do you see a polynomial?
Well, no, but
Okay, so that's a problem. Also, I can't put it here because our whole problem is we don't know the antiderivative for the natural log. So I can't put it here because we're figuring out the antiderivative.
So it's common sense. That's why I didn't get it.
Okay,
I have the
So,
answer.
you-
really nicely.
times
Yes,
v minus the integral of v du.
I like this lesson.
Right?
That's a good one. That's a good one.
That worked out really nicely. I'm very happy.
What is this? It's the integral of
DX.
1, okay, 1 dx. So we have x, natural log of x, minus, let's see.
I do have to say that worked out much nicer than I thought it was going to.
Just gonna throw us a nasty one after this. I just got a bad feeling. I see why you're not employed.
One.
Are we ready for the next one?
Yeah.
Should we step it up a notch?
Oh, we should.
Kick it up a notch. I'm
Wow.
ready. Go.
Just kidding. That's like the same.
Why did it say end again?
Write it down.
What do you mean end again? Stop making mouth noises.
Good.
All right, Benjamin.
Mhm.
The integral of e to the x squared. First of all, is this a candidate for u substitution?
No.
It is not. I see the x squared and the x, but they're not placed in the right places. Okay. So since this is a product, we could try integration by parts. What would we let u equal?
I got a 50-50 shot at this. And I got a good feeling that it might be x squared.
Okay. Which would leave e to the x dx for our dv.
Couldn't you use either of them?
Technically, yes. But
It would just
I don't think that you would get to a very good place if you had x here. Because our whole problem is we have x squared e to the x, right? Well, if you put x squared here, we get 1/3 x cubed. And then when you put the v and the back in the integral, you're in the same place. So that's why I say you want your powers to go down, not up, for your polynomials. Otherwise, you're working backwards. Okay? So let's see. Du is 2x dx, and v is e to the x. Agreed?
Yeah.
Okay. So this integral is x squared e to the x
Minus
minus the integral of
EDX.
e to the x times 2x dx. Well, baloney. We can't do this integral without
No.
Integration.
No.
integration by parts.
No.
Okay?
No.
So we have x squared e to the x minus 2 times the integral x e to the x dx.
We already know that.
Technically, we already know this, okay? We did this just moments ago, right? where we let u equal x,
The and again.
dv e to the x dx, where du was dx, I'm just reminding you, and v was e to the x. So this would become x squared e to the x minus 2 times the quantity u times v minus the integral of v du. Okay, which is what we just did. Was it 2 examples ago, 3 examples ago? I don't even remember at this point. Okay, so integration by parts helped us, but then we had to do it again. Okay, let's use some vision here. If we had x cubed e to the x, how many times do we have to do integration by parts? 3 times. Okay, now, kind of annoying.
It's gonna show up on a test.
Is there some sort of pattern that you think that we could, I mean, there's a pattern to this, right? As we chunk it down.
Oh, wait.
Okay, so I'm going to teach you,
Pattern.
The shortcut.
I'm
the
going to teach
cheat
you a
codes.
shortcut that cannot be used every time. This can only be used if you have something polynomial in your integration by parts integral. That's the only time this is going to work. Did you hear them all?
Something polynomial in your what?
You can only use this when your integral has a polynomial inside the integral, and you're going to use integration by parts. Okay. So, call it the table method. Okay. So rewrite down the same example, just so you know we're doing it again. Should we get the same answer? Yes, we should. So you're going to pick a u and a dv, and you're going to break that polynomial, or you're going to break that integral up, and then with the integral left over, you're going to pick a u and a dv. And so we have this pattern where we kept differentiating the polynomial, right?
Yeah.
And then we kept integrating whatever we had here.
Yeah.
Okay? So what we can do for our table method, I'm going to make a table, D for differentiate, I for integrate. So I'm going to put my polynomial here, and I'm going to put my other piece here. And what's going to happen is you are going to differentiate until you get to 0. So x squared, 2x, 2, 0. Bless you. Okay. Now, when we do integration by parts, we keep subtracting, and then we break it up and we subtract again, and we break it up and we subtract again. Well, when you subtract a subtraction, it goes to positive, and then you subtract a subtraction, it goes to negative. So, what we're going to have to do is we're going to have to make sure we alternate signs. However long it took you to get to this 0, you need to do that many integrations in the right column. Well, this is rough.
Very cool.
I gotta say that's.
How'd you do it so fast?
Plus minus as well.
Okay, now, we match up the V with the DU, right? So V, DU, V, DU, V, DU.
Wait, those just the same thing. I just messed up.
So our answer to this integral is x squared times e to the x plus negative 2x times e to the x plus 2 times e to the x plus c. Isn't that so cool?
That's pretty cool.
It's my favorite.
I do gotta say that is quite nice.
Neat.
Quite
And
neat.
efficient, isn't it?
I would have to
That took
concur.
us way less time than what we did just before.
I would have to concur.
Benjamin, you have a question?
I like the bees.
I don't think so. I'm just worried I'm going to use this when I'm not supposed to use it. So when am I
Okay.
not supposed to
Well,
use
if you don't get to 0, this method's not going to be okay.
it? Okay.
And if you can't integrate simply, like if you have e to the x squared, you can't do the antiderivative of that, and so it's not going to work. If you have a product right here, it has to be a simple rule for your integration.
Mhm.
Okay, let's try another one, maybe one that looks a little bit different. But I'm going to change this to x cubed.
Well, no.
Just in time. We have like 3 minutes. And this will take you longer to like write down than to do the work. Okay, so is this a candidate for integration by parts?
Yes.
Huh?
We have a product, okay, and it's not a product we can use U substitution with. It is a candidate for our table method because we have,
The x cubed.
okay, so x cubed, 3x squared, 6x, 6, 0.
Yep.
And then we do plus minus plus minus plus.
Oh, this is a trickier one.
Not good.
Sign it.
So sine of x is what we're going to integrate.
Yeah.
What's the antiderivative of sine of x?
Cosine x. Nope. Yep. Negative.
Positive sign.
Positive.
Or is it negative?
Negative
on
sign.
loss?
Okay, now I'm confused.
What?
It's negative.
Oh. I was doing the derivative.
Oh, so
The antiderivative. Okay, did not know that.
negative sign. The next one.
opposite.
Yeah, we're going backwards.
Cosine.
And then
Lines.
we angle down.
Right, now we got the answer.
Okay. So our answer is x cubed
Oh, no.
times negative cosine of x plus negative 3x squared times negative sine x plus 6x times cosine of x
I didn't fit it.
plus negative 6 times sine of x
Just waste tree.
plus c.
Waste the trees.
It's the exact same amount of room.
Aren't you glad we have the table method so we didn't have to do integration by parts?
I don't know. I think integration by parts might have been a fun challenge.
Do you want to do that?
If you'd like to, go for it. I mean, I'm just telling you, when it comes to the AP test, we want to be efficient with our time.
I like the.
I mean, technically, but are they really going to give us one this
I like
easy?
this almost as much as.
Realistic? Well, maybe on
Yes, they will.
multiple-choice.
There will be a problem like this on the multiple choice of your AP test. I guarantee it. Whether it be like x squared times e to the x or x cubed sine of x, like, it's going to be on there.
Point of interruption, couple of weather announcements related to activities. No reserve boys tennis today. Reserve boys tennis is canceled. Metro cross country has been postponed, not canceled, postponed today